Thank you for that introduction. First, I'll go through a high-level description of our device. Effectively, it's similar to a device that you'd find in almost any hospital around the world. Magnetic resonance imaging, MRI machines are very common, and we use the same molecular phenomena, which is to apply magnetic force at the subatomic level and the atomic level. And so what happens is our device, instead of producing an image, produces something that looks akin to an EKG or something, an output from a Richter scale. Then to normal human beings, like myself, it doesn't make much sense, but to PhD chemists, they can use that output and understand what the shape, size, and concentration of a solution is at the molecular level. So, for example, we can use this in cannabis trim. So what happens is you trim the flower and they can sell that in the stores or what have you. But what they need to know in order to produce optimal results is when you have, say, extra leaf or the stalk, is there enough cannabis content, i.e. CBD or THC content in that extra trim in order to justify processing? So we can do non-destructive tests of that kind. And right now, the market for nuclear magnetic resonance spectrometers sits around $1 billion globally. And so most of that market right now is made up of high field, large machines. These machines, as you're about to hear, are the size of a room. They have to have a professional operator. They have to be liquid cooled with liquid nitrogen, and they're very difficult, very sensitive machines. Now, our machine is quite a bit more resilient. It uses permanent magnets, so no cryogens. And so effectively, you can reset the machine or recalibrate the machine with just the press of a button. It takes about 30 seconds to a minute. So how is this market going to grow? As I said, these are the existing tech that's been around for about 30 to 40 years with using these high field devices, the size of a room, sometimes as heavy as a truck. These devices can't be put into a manufacturing plant. They can't be put in situ. So our devices are very stable, very small. They can be put in glass-proof cases, and they can be put into very hostile environments. Think oil refineries, chemical plants, not to mention R&D labs and research facilities around the world. So we expect not only to take some, but not all of the existing $1 billion market, but we expect that this market will grow substantially. It's worth noting that every other major chemical analytical instrument has gone through the process of miniaturization. NMR is the last device to do so, the last class of devices to do so. And so I think and we believe that there's a very strong possibility this would be hitting an inflection point in terms of industry adoption very, very soon. And there's good reasons to believe that. And so one of the reasons we believe that so strongly is because we have seen a lot of interest from a number of different major corporations around the world, major industries, all coming together and saying, we want to look more closely. And an example of that is an announcement that we just made late last year with the LKA, which is the police force of Lower Saxony in Germany. And in collaboration with them, we put our devices in mobile police labs so that they can do on-the-ground testing in real time of suspicious substances. Now, of course, NMR is still being used every day by police forces and security forces and drug companies of all kinds. But what our device can do is identify whether or not suspicious powder is fentanyl or heroin or not. And you can do it within minutes. There's no need to send it away to a drug lab and take days and days. You can make the arrest with a high degree of certainty at that time, rather than, letting the potential dealer go and then maybe having to track him down again, wasting time and resources. Additionally, when you deploy these things, we believe that when you can deploy these things throughout a police force or a group of police forces in collaboration, what our devices can do is, let's say a fentanyl shipment comes into San Diego Harbor, and for whatever reason, some but not all of the shipment is caught at the harbor that day. So we can see that test being done. It'll go up into a cloud database, and as the shipment moves throughout its supply chain and additives are put in as cutting agents and what have you, you can see the major distribution hubs for that particular shipment. and each one will have a unique chemical fingerprint. So one batch of fentanyl will not be the same, will not look the same to a PhD chemist, i.e. our machine or the user of our machine, as the next batch. There'll be a slight difference in how the chemical reaction took place on the manufacturing end, and we'll be able to identify that. Now, how is that useful? Why should you care? The reason why you should care is we'll be able to say, okay, this particular batch of drugs that happens to have a fatality rate of X is now moving, and we know the supply chain because of past mappings, so we can tell that this map of drugs will hit, say, Boulder, Colorado in 3 days from San Diego. And so we can, or the police forces will be able to notify their partners over in Boulder, Colorado, or wherever else, hey, this particular batch is coming through. We're seeing a high risk, high fatality rate from users, and you should probably increase your frontline hospital staff, perhaps get some Narcan kits for overdoses, and perhaps even deploy more frontline police officers to stop this shipment. So we think that this is only one of the many, many applications, and Sean, our CEO and founder, will be pleased to walk you through more of these in just a moment here, but we think this is an exciting opportunity, and we welcome any questions you might have for Sean after the presentation. Thanks for your time, and I hope you join us as shareholders.